So welcome to the Arena Training Centre series of videos on rearranging formula, something which a lot of trainee electricians and indeed qualified electricians seem to hate doing because it is maths. But really, it's very straightforward, and hopefully this series of videos will help you to become a little bit more confident. So first thing that most people often ask is, why are we using letters instead of numbers? And I might ask you the question, how much cash is there in my pocket? And of course, you can't answer that because you don't know what that value is. So what we can do is we can give that value a letter. Doesn't really matter what the letter is. We'll give it a letter M for money. And we can build an expression using letters and numbers. Now, let's just, for the sake of argument, say that someone gave me 50p to put in my pocket. If I was then asking the question, how much money is in my pocket, a lot of students would say 50p. But you've forgotten the fact that there's this unknown amount of money in my pocket. So after adding 50p, I could write the expression M plus 50, and that would be the amount of money in my pocket. So we simply use letters wherever we wish to use a value of which that value is not known. And of course, if I was to tell you the value of M, which in this case today is 0, then we can solve the equation by substituting the letter for the actual value, solving the equation, which would be 50p in this particular instance. So the first thing to get your head around when it comes to rearranging equations is understanding how the equals sign works. And I like to think of the equals sign as being the centre point on those old-fashioned balances that you used to get in the sweet shops. You used to put weights on one side of the balancing scales and then sweets on the other side. And when it balanced, you could see how many grams, or back in the old days, how many ounces of sweets you'd got because they would balance. And if you were to add weight to the left side, as long as you added the same weight to the right side, it would still remain balanced and equal. And the same is true for an equation, like we've got here. So I've got 2 plus 1 equals 3. And I can do anything I want to that equation in terms of writing anything I want on this side, as long as I do the same to the other side. So let's just add 1 to this side. As long as I do the same to the other side, it still remains true, because 1 plus 2 plus 1 is 4, and 3 plus 1 is 4. So let's take a very basic example here. People often say, oh, I can't do algebra and I can't rearrange formulas. Then I write this on the board and ask them what do you think the value of x is. And of course, they'll all say 1, because 2 plus 1 is 3. This is a very simple example, but how have we actually worked this out? Well, Westerners tend to read from left to right. So as a mathematician, I would want something that reads x equals, and then an answer on the right. In this particular case, the x is on the left-hand side of the equals, so that's in the correct place. But unfortunately, it's being added to plus 2. But remember, we said that we can do anything that we want to an equation as long as we're doing the same to both sides. So I can get rid of this by simply writing minus 2 on this side, but I have to do the same to both sides. And a 2 take away 2 is nothing, which leaves me with x. 3 minus 2 is 1. And that's how you calculated the value of 1 mathematically. So let's look at another example. In this particular one, we've got 12 equals 7 plus x. And I want to calculate what the value of x is. Mathematicians would say, make x the subject of the equation, which basically just means make it so that it says x equals. Unfortunately, the x is on the right-hand side of the equals. And as I said, Westerners tend to read from left to right. So we want this on this side. And just as we said with our balancing scales, once they're balanced, if I was to take this basket off and swap it with this one, it would still be balanced. So first of all, I'm going to take this side and write it on the left side, and I'm going to take the left side and write it on the right side. I've basically just flipped the equation, but I want x, and at the minute I've got 7 plus x, so to get rid of this 7, I'm going to take away 7 from both sides. The 7 take away 7 leaves me with x. And 12 minus 7 is, of course, 5. So x is. So we've done adding, I've done subtracting. What about multiplying? This expression here, 2x, actually means 2 times x. Mathematicians have an agreement that where the number is written in front of a letter, that simply means to multiply. So I want to know what the value of x is. Well, first of all, it's on the wrong side of the equals. So the first thing I'm going to do is I'm just going to flip the equation. Now I want to just calculate what the value of x is, and at the minute the x is being multiplied by 2. The opposite of multiply is divide, so I'm going to divide both sides by 2. Now of course when you divide any number by itself, you get the value of 1. 1 times x is 20 over 2. But of course, 1 times x is just x. So effectively, we've got rid of those two numbers there, and we're left with x equals 20 divided by 2 is 10. So in this particular expression, we have x divided by 4 equals 5, and I want to know what x is. So I need a formula that says x equals. The opposite of divide is multiply. So I'm going to multiply both sides by 4. But of course, when we multiply this side by 4, we have 4 divided by 4. And as we've seen previously, that is equal to 1. And 1x is just x. So these have effectively been removed from the equation. And 4 times 5 is 20. So x is 20. So next we're going to look at squares and square roots. So it'd be helpful to understand exactly what squares and square roots mean. So 2 squared is a mathematician's way of saying 2 times 2, which in this case is 4. So when you square a number, multiply it by itself. The square root of 4, that's a mathematician's way of asking the question, what number multiplied by itself is equal to 4, which in this case is 2. So here we have an expression 100 equals x squared. I want to know what x is equal to. So the first thing I'm going to do is swap the two sides. So now I've got the x on the left-hand side of the equation. Now remember we said that the opposite of squares is square root. So if I square root both sides, it's still balanced, it's still equal because I've done the same to both sides. But when you square root a square, you end up with the root value, which in this case is x. And of course, the square root of 100, you can type that into your calculator, but square root of 100 is 10, because 10 times 10 is 100. In this example, we have the square root of x equals 4, and I'd like to know the value of x. The x is already on the left-hand side, so I don't need to flip the equation. However, I do need to get rid of this square root. The opposite of square root is square. So if we square both sides, the equation is still equal because I've done the same to both sides. But when you square a square root, you end up with the root, which leaves me with x. And 4 squared is 4 fourths, which is 16. So, having learnt how to rearrange equations, we can now put that to some use. As an electrician, we're going to be given various formulas. It will be useful to be able to rearrange those formulas so that they are expressed in different terms. This is Ohm's law. At the moment, Ohm's law is being expressed in terms of V. That simply means the equation starts with V equals. But what if I wanted to know what I equals? Well, we can now use the rules that we've learnt from rearranging formulas to jig this equation around and write it so that it says I equals. First thing that you'll note is that the I is on the wrong side. So the first thing I'm going to do is just simply flip the equation. A bit like taking the two pans off the weighing scales and swapping them around. It's still equal, still balanced. But now I've got I times R, and I only want the I. The opposite of multiply is divide. So I'm going to divide both sides by R. But when you divide any number by itself, you get the value of 1, and 1i was just I. So this cancelled out, which leaves me with I equals V over R. Now we could start with the formula P equals IR and ask the question, well, what does R equal? So the same process, I'm going to swap the two sides so that the R is on the left-hand side. Now in this case, I want to leave the R, but I'm multiplying the R by I. So the opposite of multiply is divide. So I'm going to do the same to both sides. But when you divide any value by the same value, you end up with 1. And 1 times R is just R. So this is cancelled, which now leaves me with R equals B over I. So in this particular example, we're going to calculate the value of x. X is on the wrong side of the equation. And that is also that x is on the underneath of this equation. The top line is being divided by the bottom line. So to get x on the left-hand side of the equation, instead of swapping it, this time what I'm going to do is I'm going to multiply both sides by x. So I'm just going to write x times on both sides. Still equal because I've done the same to both sides. But x divided by x, any number divided by itself is always 1. So this cancels out. So I've now got 50 x's. I've rewritten that. 50x just means 50 times x equals 100. And now, my final step, I want x on its own. At the moment, it's being multiplied by 50. So I'm going to divide both sides by 50. It's still equal because I've done the same to both sides. But 50 divided by 50 is 1. on 1x is just x. So x is 100 divided by 50, which is 2. So here's a formula that you might come across in the studies. This is the formula for capacitive reactance. But what if I was to ask you what the value of C equals? Well, that previous example should help us do that now. The C is on the wrong side of the formula, and it's on the underneath of the line. The first thing that I'm going to do is I'm going to multiply both sides by C. So I'm going to multiply this side by C, and then I'm going to multiply this side by C. C divided by C is 1, so this effectively cancels out. So let me write it without the multipliers now. So I've now got C multiplying xc equals 1 all over 2 pi f. But I want C on its own, and at the minute it's being multiplied by this value xc. So I'm going to divide both sides by xc. So let me write that out again so that you can see what I've done here. But remember, xc divided by xc is going to be 1, so that's cancelled. So C equals 1 all over 2 pi f x c.